This might be rough. Let's see if we can straighten this out. So, it says, you're climbing a mountain by the steepest route, and the slope you're walking up is 20 degrees. Okay, so here you are. You're walking up that way by the steepest route, and that slope is 20 degrees. 20 degrees. Okay? The next sentence says, you see a branch, right, a trail off to your side, that's going off at 30 degrees to your side, right? And this is hard to draw. That means there's a branch this way, right? That's 30 degrees. So here you are walking uphill 20 degrees. Over that way 30 degrees, there's another trail, which is presumably also,
Still 20 degrees.
See, okay, now I get it.
it's not 20 degrees,
Not?
but it's definitely uphill still.
Yeah.
You guys see that? How do I know it's uphill still?
You can see it.
Because I can see it.
30 overpowers 20.
Well,
No
if it were
longer
90
Yeah.
degrees or less, then
Yeah,
must
it would
be
hit-
uphill.
Yeah. If you're looking up the gradient vector, right, to your sides are the level curve. You guys all see that? So 90 degrees each side is a level curve. You're looking up the steepest bit. So if
30
you're
degrees
not
up.
looking at least 90 degrees, you're still looking uphill.
Assuming you're not on a saddle.
So 30 degrees off the grid.
I know I'm not on a saddle because I'm going uphill and the slope is 20 degrees. If I was at a saddle, right? Oh no, I
Seems
don't
like
know
you'd
I'm
be
at a
going up
saddle.
a saddle,
It
it
doesn't
would-
matter.
Okay.
If I was on a saddle, right, I'd still be looking at this slope of 20 degrees, and the level curves are still, instantaneously at least, off to my sides.
What's ascent? Ascent. Oh, ascent.
Ascent. Did I spell that wrong?
I don't know. I was looking.
Okay, so my best guess for this is what?
So this is 20
Maybe
degrees.
making a vector 30 degrees to the gradient vector.
Okay. Yeah, really this is asking, right? What's the directional derivative in 30 degree for 30 degrees, right?
So your magnitude of the vector is the angle at which it is.
Yeah. You guys all see that?
Right.
Okay, so let me see. So here's my gradient vector, right? I'm facing that direction. There's this 30-degree angle here. Right? Okay. How do I make a unit vector that points at 30 degrees? What are
The
the
vector
components?
under the divided by the magnitude.
Okay, I need a vector that's divided by the magnitude.
So,
But I. Okay. Let's see. So
make a vector.
yeah, I just need to make a vector u that's 30 degrees off to one side or the other, right? Okay, so I'm just gonna throw some coordinates out there, right? I'm just gonna declare the gradient vector is in what's the easy direction?
1, 1,
Like you're standing here, what's that way?
1, 0.
Yeah, like maybe
Or
the
one.
x-axis, right?
Yeah.
Okay, so I'm just going to assume the gradient vector is along 1, 0. Right? It's got a magnitude, right?
Yeah.
Well, it's got a magnitude that would tell me something about 20 degrees, right? Let me worry about that later.
Okay.
For right now, I'm just going to go with, all right, there's a magnitude, whatever. It's pointed in the x-axis direction just because I picked a direction, I'm calling that the x-axis. What's 30 degrees off to the right of the x-axis? Or left?
One power of 6 or cos powers.
30 degrees.
you want this vector to be 1 long, right? Okay, so here's 1.
There's your 60, 90,
The coordinates of this one are going to be like this, right?
It'd actually be 3/2, and the y would be 1/2. Yeah.
Is that right?
Mm-hmm.
Does all buy into that?
Okay.
So the way I would have gotten this is I would have said, okay, the opposite side is the, right? That's the y value. That's the sine of 30 degrees. And then I would have said, okay, this side, that's the cosine. There we go. Check. All right. So there's my unit vector. And what do I want to do with that?
Find its magnitude.
Dot.
I know its magnitude. It's 1. I designed it that way.
Oh, okay.
Then I want a dot product with the gradient vector, right? That'll give me the directional derivative. So what am I going to get here? Take this, dot product with your gradient of 1.
We're just going to get root 3 over 2.
You're going to get root 3 over 2, right?
Now we're gonna do some like proportion thing between the magnitudes.
Yeah. So, what's my proportion thing in terms of magnitudes?
So what is root 3 over 2? What is that measuring?
So that's measuring, this guy is the dot product of the gradient vector and, or gradient vector, whatever the heck function I'm dealing with, dot producted with a unit vector pointing in 30 degrees. Okay, so this thing is going to be roughly the percentage that the slope I'm looking at, right, my 30 degrees offside, how much does that agree with the gradient vector?
So the rate that it's increasing relative to the horizontal.
Yeah.
Okay.
So how long is my magnitude vector? Well, I don't know. It's got something to do with 20, right?
20.
So I'm going to say 20 is to 1 as whatever this thing is to the slope that I'm looking for. You guys see that? What's that going to boil down to?
Math calculator. Whatever.
Math calculator. Multiply this thing by 20 degrees. Yeah, it's all got 10 root 3 degrees.
And that's like assuming the branch is sticking out perpendicular to the tree and the tree is perpendicular to the ground.
No, no, no. This is assuming that the trail that I'm looking at goes straight.
Oh, a branch in the trail, not like a branch on the tree.
Yeah.
Thank you.
Yeah, there's no tree.
Oh,
Well,
I
I
think
think
it's a tree.
We're outdoors. I
Right?
think trees and branches.
No, there's not a tree.
There's
Oh.
probably lots of trees.
That's why I was confused.
All these you see are illusions.
Okay, so should we illustrate this on the ground? The answer is 10 root 3 degrees, right?
Okay.
Which is like, give or take, what,
15-ish.
15 degrees or something?
18.
Is that a reasonable answer?
Sure.
Yeah, probably. You guys want to see it on the ground over here?
Yeah.
Okay, so... Woo! We lost a leg!
There was a tree.
No, there's no
There's
tree.
another trail.
Okay, so... Here, hold this.
Part of this says angle of ascent.
Okay, so here I am, walking along, right? I'm looking straight up the steepest part of the hill. So I know that this, right, is 20 degrees off vertical, right? And then if I look 30 degrees off to the right-hand side or left-hand side, you guys see that those are the same steepness? So what we're saying is, okay, and I picked left because there's poison oak on the right. If I branch off at 30 degrees, how steep am I going uphill there? You guys see that? It's almost as steep, but not quite.
So the 30 degrees that you're branching is 30 degrees from the 20 degrees one?
So it's 30 degrees from the direction. So if I was holding a compass in my
Oh,
hand,
okay.
right, I'd have that way is 0,
Uh-huh.
and this way is 30.
So the angle of ascent is which part?
Yeah, so then the angle of ascent is the angle that this thing makes with a horizontal plane.
So that 10 root 2 is
Does that make sense?
I think so.
Makes a lot more sense than trees.
when you physically do it, yeah.
So those
So long
sticks
as the
look
tree's
like
not
this,
there,
right?
Uh-huh.
Yeah.
So it's the angle that these make with flat ground.
Okay.
And it's
Right,
going to be
so-
less than the gradient because the gradient is the steepest.
Exactly, right? So if I'm going to go in the gradient direction, right, that's the steepest I can go. Anything off the gradient is going to be less steep. Cool? A good estimate for this might be just to say, okay, it's right, 30 degrees is a third of the way to 90, right? So this should be a third of the way from 20 degrees to flat.
Mm.
Right, so I would expect something in the neighborhood of like 17 or a little less degrees. And it turns out that's pretty close to the 10 root 3 degrees we got.
Oh, so it's about 2/3.
Cool.
Just
Yeah,
less
it's
than
about
20.
2/3 of 20. Cool?